So I'm going to start teaching you guys about parent functions, and we're really just dealing with linear and absolute value functions to start. So a family of functions, or a function family, is a set of functions whose equations and graphs have similar form and shape. So the first one, you see all these lines. This brings us back to 8th grade. These are linear functions. And then to the right, we've been dealing with these all week, are absolute value functions. And if you remember back in algebra, a parent function is the simplest function of the family. Give the parent function for each function family, then graph the function. So for linear, remember, we'll say f of x equals x. So just the line x, that means our slope here is 1 and our y-intercept is 0. So that means we start at 0, we go up 1 over 1, up 1 over 1, up 1 over 1. And I'm just going to connect the dots. So that's our parent function for linear functions. Next is absolute value. So our equation for the parent function would just be f of x is equal to the absolute value of just x. And that means our vertex starts at 0. And again, we have a slope of just 1. And then remember, absolute value is like a v. So we do the same thing on the opposite side, but we just make sure we go up instead of down. So then what we're dealing with today are transformations. So we start with these parent functions, and then we either slide them to the right, the left, up, down, or you can make your absolute value skinnier or bigger. So what I'm going to do is, in my calculator, notice I put the absolute value of x. I want to see what happens to that when we do x plus 2. So then I'm going to hit second math number, absolute value, and we're going to put x plus 2. And I'm going to hit graph. So the first one is our parent function, and then the red one is our x plus 2. And notice it just went to the left 2. So left 2. We're going to go through again. Let's look at number 4 is x minus 2. So I'm just going to change this to a minus. And let's see what happens. There's our original. So when it's minus 2, we go to the right 2. So now let's try absolute value of x. And then we're going to change this to, so let's delete that, delete that. We're going to do plus 2 on the outside. Now let's see what happens. Okay, so it moves it up 2. And now for the next one, it's x minus 2. So I'm assuming it's going to go down 2, but let's double check. And I am correct, it goes down 2. So it's really nice that we can even check with the calculator and kind of figure it out from there. So that's like a nice little tip. So let's go back to y equals. Let's do 2 times x. So let's delete this, and let's second insert a 2 in front. And let's see what happens. Ooh, so it became skinnier, so that's a vertical stretch by 2. So then let's go back into it. Let's see what happens with 1/2. So I'm just going to do second insert and put 0.5 and delete that 2. And I noticed this one just got wider. So that's a vertical compression by 2. And let's do our last one, which is negative absolute value. So we're going to go in here. I'm going to make this into a negative sign. Let me delete that point. Let's see what happens. Oh, it just flips it. So it reflects over x-axis. All right, so thank you, calculator, for helping us. So let's go over the different types of transformations. A translation is a slide. A stretch is a dilation. A reflection flips it. Let's flip over to the back. Now we're going to define these rules. This makes it a little bit easier instead of having to go into your calculator. So whenever we do x plus h, we shift left h units. X minus h means we are going to shift right h units. When we do f of x plus k, that means we're going to shift up k units. F of x minus k means we're going to shift down k units. All right, so remember when we did 2 and then 1/2, so if it's a number greater than 1, so if it's a number greater than 1, it's going to be a vertical stretch. And when it's a number less than 1, so a fraction or a decimal, it's going to be a vertical compression. And if we negate our function, then it will reflect across the x-axis. So then these are like the typical questions we get with transformation. So we have to look at the function, so it's absolute value, and then outside of the absolute value we have -3. So that reminds me of this rule here. So that means we're going to shift down 3. For this one, we have x plus 7 inside the absolute value. So that's going to be like this. So it's going to shift left 7 units. So there's two things going on here. First thing I notice is the -4. So we're going to be going right 4. And we're also got this negative, which means we're going to reflect over the x-axis. Over here we have two things going on. The first thing is I see this +1, which tells me I'm going up 1 unit. And what else are we going to do? The 4, which is greater than 1, we're going to stretch by 4. And then we're going to shift up 1. Next, I have 1/3, so that's less than 1. So that's vertical compress by 1/3. Number 15, I noticed the x plus 2, so that would be shift left. And then the -5 means down 5. This one has a lot going on. I noticed the -2. So the first thing I noticed, it's going to be stretched and it's going to reflect over the x-axis. So let's start with reflect over x-axis, stretch by 2. And we have this x minus 1, which means we are shifting right 1 unit. And then we have another big doozy one. So the 4/3, that's actually greater, so that's a vertical stretch. And the +2 means and up 2 units. So I like these kind of questions because just using this table makes it very easy. So now for the writing it ourselves, we're going to write the transformations to the absolute value. Parent functions are described, write the new functions. Translated 6 units right, so f of x equals, I'm going to do my absolute value. Units right means x minus h, so we're going to do x minus 6. Reflected in the x-axis, so that means there needs to be a negative in front. Then translated up 2 units, so that's absolute value, and then we do +2. I think I should just write f of x at the beginning of everything, just so I don't forget. Vertically stretched by a factor of 5, so that means there's going to be a 5 in front. And then translated 1 unit left, so that means +1. Translated 3 units right and 4 units down, so that's going to be a lot of minuses, so x minus 3 minus 4. Vertically compressed by a factor of 2/3 and reflected over the x-axis, so there's a negative there. So I'm going to do negative 2/3, absolute value x. Vertically stretched by a factor of 2, so we're multiplying the absolute value by 2, and translated 9 units down, so that goes outside as -9. And the last one, vertically compressed by a factor of 1/4, so that's getting multiplied, and shifted 1 unit left, so that's x plus 1.